Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Saytzeff's rule states that in elimination reactions, the more substituted, more stable alkene is the major product. Hofmann's rule applies when bulky bases or specific leaving groups, like NR3+, force formation of the less substituted alkene. Moving on to the next step. Analyze each option for whether Saytzeff or Hofmann product predominates. Option A. This is an E2 elimination of a quaternary ammonium salt, Hofmann elimination. Ammonium salts are poor leaving groups and follow Hofmann's rule, giving the less substituted alkene as major product. So Saytzeff product is not major here. Option B. CH3CH2CH2CH, F. CH3 with IChO moderately sized base. Fluorine is a poor leaving group in E2 due to the strong CF bond. Also, F tends to give Hofmann type selectivity. The less substituted alkene tends to be favored. Saytzeff product is not reliably major here. Option C. CH3 CH2C CH3 Br CH3 with T-book, bulky base. A bulky base like T-book favors the less hindered, less substituted, proton abstraction, giving the less substituted, Hofmann, alkene as the major product. So Saytzeff product is not major here. Option D. CH3CH2CH2C, Br, CH3, CH3 with CH3OK, small, non-bulky base. CH3O is a small base, and with a simple alkyl bromide leaving group, Saytzeff's rule applies. The substrate has a tertiary bromide. Possible alkenes, removing H from the CH to CH2 side gives a more substituted, trisubstituted, alkene, while removing H from one of the CH3 groups gives a less substituted, disubstituted, alkene. With a small base, CH3OK, the more substituted Saytzeff alkene is the major product. And for the final step, only option D uses a small base, CH3O, with a normal alkyl bromide leaving group under conditions that favor Saytzeff elimination. Therefore, the correct answer is D. Therefore, the correct answer is option D.